Okay, I welcome all of you to today's class. So we are about to start our fifth chapter. This is the fourth lecture of theory of machines. This is the fourth lecture of theory of machines. We are going to cover three chapters here in this fourth lecture. What are those? Kinematic and dynamic analysis of slider crank mechanism. Can you hear me? Am I audible? Good. Am I audible? Fantastic. So we'll cover up three chapters here in the fourth lecture: kinematic and dynamic analysis of single slider crank mechanism. Thereafter, we'll cover up flywheel, and then we'll cover governors. Right. So three chapters in this packed 2 hours of class. Okay. So let us start. Let us start with kinematic and dynamic analysis of single slider crank mechanism, right? So here you can see this is a single slider crank mechanism, right? Single slider crank mechanism. So which one is the slider here? Slider concept. This is the slider, right? You already seen this mechanism, right? You know, simple mechanism. So this is the piston. Sorry, this is the slider. Slider, that is the piston. Nothing else but the piston. Nothing else but piston. Then this is the cylinder. Cylinder is fixed, right? This is the connecting rod. This is the crank, right? And the crank will be fixed here in the crank pin. There is a hinge joint here, hinge joint, right? Hinge joint. Turning pair, we already know, we have already seen, right? So how is this going to function? How exactly is this going to function? This is something like this is going to function in some this kind of scenario. देखते हैं how exactly it is going to function. For example, the crank will rotate. The crank will rotate. If the crank rotates, the connecting rod will get pulled. The connecting rod will get pulled. The crank rotates. The connecting rod will get pulled. So what will happen? The piston comes this side, right? So this will happen in case of reciprocating compression, right? But here what we are going to study is, right, with respect to an IC engine, right? In case of reciprocating compressor or uh, compressors, right? What exactly will happen? The crank will rotate. We'll have a motor attached here. We'll have a motor attached here. The motor will drive the crank. The crank will drive the connecting rod. The connecting rod will pull the piston, right? And there will be suction and compression, right? And which will lead to uh, compressing of air. And that is a completely different subject, right? We are going to study it in the point of view of with point of view of IC incident. देखेंगे, ठीक है? We are going to see that, right? First, we will do the kinematic analysis, then we will do the dynamic analysis. This chapter contains both kinematic and dynamic analysis. First, we're going to do the kinematic analysis, right? So, in kinematic analysis, what we're going to do is we'll find out the displacement of the piston, the velocity of the piston, the acceleration of the piston, the acceleration of the connecting rod, and the acceleration uh, of the angular acceleration of the connecting rod. ठीक है, देखेंगे all these things we are going to see, right? But unfortunately, we will not be able to derive it, right? Unfortunately, we will not be able to derive it. Just hold on, just hold on. Sorry, my screen share is still on. So okay, so now let us first learn a few things before getting into let us learn a few things before getting into the uh, say into the actual thing. Unfortunately, we'll not be able to derive it. Yes, I'll only give you the formulas. I'm sorry for that, but we don't have time to derive each and everything here, right? So first, let us see few things, right? So what is m? M is the mass of the reciprocating part, which is the reciprocating part here. This is the reciprocating part. This is a mass m, right? Then you have L. What is L? L is the length of the connecting rod. Which one is the connecting rod? This is the connecting rod, you can see, right? The length of the connecting rod is L, right? Then what you have? You have R. R is the length of the crank. This is the crank. This is the length of the crank, you can see, right? Then we define a term which is known as obliquity ratio. We define a term which is known as obliquity ratio, right? Obliquity ratio is L divided by R, that is length of connecting rod divided by length of crank. Generally, this ratio remains greater than 1. It will be in the range of 4. It will be in the range of 4. Generally, it will be in the range of 4, right? Then we have angular velocity. What exactly is angular velocity? Omega, right? Omega can be written as d theta by dt, that is rate of change of angle. Which one is angle theta? Let me show you. This is angle theta. This angle theta, right? So what is angle theta? Angle formed by the crank from top dead center to top dead center or bottom dead center. Okay. So this angle is theta. Mind you, this angle is beta. These are some of the common terms that you need to remember. This angle is beta. That angle is theta. And these are some of the things you'll have to see. Okay. So what is the displacement? The equation for displacement. Unfortunately, I'll not be able to derive it. We don't have the luxury of time today, right, to derive it. But yes, you'll have to remember, better to remember this formula, right? This is the displacement x of the piston. Right? Yes, I know there will be some amount of clearance, right? So whatever the piston is displaced, how much the piston is displaced, we can give it by this formula. How much important is this formula? I'll say the next formula is more important than this. Take a displacement formula. Yes, they might ask you, but this is not that very important. And also, I can completely understand this is very, very tough to remember, right? When you ask me without revision, no, not possible to remember this formula so easily, right? Okay, I will let in Praveen also. Yes, Praveen. Hello, Praveen. I hope you can hear me. So this is the equation for displacement of the piston. This is the equation for the displacement of the piston, right? If you differentiate this equation, yes, you have to remember this equation. There is no other way out. But okay, even if you're not remembering this, the next equation is much more important. The next equation is much more important. That is the equation for velocity of the piston. So if you differentiate this equation, if you differentiate x, dx with respect to time, dx by dt, what you are going to get? You will get the velocity. So velocity is r omega. Velocity is r omega sine theta plus sine 2 theta by n. What is n here? We have already seen n is nothing else but obliquity ratio, that is r by l by r. N is nothing else but obliquity ratio, that is l by r. Now, if you differentiate this equation, differentiate velocity, right? We'll get acceleration, and the formula for acceleration is a must for you to remember, is because it is very important. In fact, even here and tomorrow, if possible, if you're seeing balancing, ठीक है, वहां पर भी देख लेंगे अगर if possible, if you're seeing balancing of reciprocating masses, it is going to be important. But this is something you should remember. ठीक है, this is sometimes directly asked in the equations. A is equal to r omega square cos theta divided plus cos 2 theta by n. So what we are talking about, all these things, we are talking about the displacement, velocity, and acceleration of the piston with respect to theta, how it is varying with theta, because the crank, our wheel rotation is dependent on this theta, right? How fast, how much is the crank rotating, and with respect to the crank, what is the velocity of the piston, right? We can all derive this. Okay. Now the second important thing is the connecting rod. Okay. We also should know the angular velocity of connecting rod and angular acceleration of connecting rod. So what is the angular velocity of connecting rod? Angular velocity of connecting rod is given by omega cos theta by n. And what is the angular acceleration of connecting rod? Angular acceleration of connecting rod can be given by omega square sine theta by n. Okay. So these two formulas are also important because these formulas are short, right? so many times direct questions are asked. Okay, unfortunately I'm not deriving it, we don't have the luxury of time. Okay, anyways, this formula, if you get time, but I don't think you'll have that much of time, I can understand, right? You might not be able to remember, but if you get time, if you have some extra spare time, if you feel that all important things are complete, then you can do this. Velocity formula, better if you can remember. Acceleration formula, must remember, right? A is equal to r omega square. See, it is very simple. Okay, agar a velocity be, even if you're remembering velocity, simply you have to differentiate. Okay, you'll get this, right? And then this too also must remember, right? Direct questions have been asked many a times. What is the acceleration of connecting rod and what is the velocity of angular velocity of connecting rod? Okay. Otherwise, numerical questions are not possible. Even in GATE or engineering service or any other exams, they have not asked numerical questions on this, right? Subjective numerical questions are there in engineering service, but not in objective. Okay. Now, what we are going to do is dynamic analysis. Now, what we are going to do is dynamic analysis. We are done with our kinematic analysis, right? I know I've just given you the formulas, but yes, we are done with your kinematic analysis. Now what we are going to do is dynamic analysis. इसमें थोड़ा सा मैं explain करूँगा, ठीक है? Because again formulas are many, it is not possible to remember all the formulas, so I will explain you a little bit here, right? So now suppose this is the piston. What is this? This is the piston, isn't it? This is what? This is what? This is the piston. This is the piston. What is this? This is the piston, right? So what is happening here? यहाँ पर क्या हो रहा है? What is happening here? Combustion, right? If this is the IC engine, what is happening here? What is happening here? Combustion. What is happening here? Combustion. So because of the combustion, the pressure will rise. Pressure of the gases will rise, and because of the pressure of the gases, so what will happen? There will be a force. There will be a force on the piston. As you can see, there is a force on the piston. This force is called the piston effort, the net force. The net force is called piston effort. The net force. What is the net force? Net force is called the piston effort, right? We will not go into very detail. क्या है piston effort? How much is the piston effort? ठीक है, let it be. ठीक है. But this net force is called the piston effort. ठीक है. The net force is called the piston effort. Net force on the piston. Net force on the piston. So you can imagine it this way. ठीक है, एक बार चलो बता ही देते हैं, right? If this is the piston, ठीक है, not full, ठीक है, थोड़ा knowledge दे देते हैं. Let me say this side area is A1 and this side area is A2. How come? Because see, this side, not the whole area will be exposed. Okay, this side, not the cross section of the piston might be different both the sides. Okay, the cross section of the piston might be different both the sides. I'm not getting into very much detail. Okay, why? Because here you will have the, here you're going to have the piston rod. There will be piston rod here, right? So the pressure, even if there is pressure, right? Even if there is pressure on this side, let me say this is the pressure P1 on this side, and there is another pressure, let me say P2 on this side. The effective area on which P1 and P2 are acting will be different. Effective area on which P1 and P2 will be acting are different. So in that case, if you write the piston effort, piston effort will be P1 A1 minus P2 A2. P1 A1 minus P2 A2. Right? This is how you can write the piston effort. Right? This is how you can write the piston effort. Right? If the diameter of the piston is D and the smaller diameter of the piston rod is small d. Suppose let me say this is small d, and let me say this is capital D. Right? You can write A1 and A2 as this way. Right? The pressure has to be given right on both the sides. This way you can write the piston effort. Then lot many other things will also come up, right? For example, friction, inertia force. If the slided crank mechanism is in vertical position, the weight of the pill also come into effect, right? So we are not considering those things, right? Because just simply let us focus on understanding the concept so that we will be able to answer it in a HL exam. Okay. Now, so this is the piston effort. We got to know how to find out the piston effort. Piston effort is basically the main uh, reason why the piston effort is being developed is because of the combustion of the gases, right? Because of the combustion of the gases, right? Fuel and gas, right? The pressure inside the combustion chamber has increased, so there is a good amount of force which will now be transmitted to the crank. वो हम देखेंगे how exactly it is getting transmitted, how exactly it is getting transmitted. That is what exactly we are going to see right now. Okay. Now, because of this piston force, some amount of force will be transferred to F to the connecting rod. You can see some amount of force will be transferred to the connect rod. Some amount of force will be transferred to the connecting rod. Some amount of force will be transferred to the connecting rod. Now, how much is being transferred to the connecting rod? How to find out? I can say, what I can say is, can I say that Fc cos of beta is equal to F? Yes or no? Fc I can resolve into two parts. I can say this is Fc cos of beta and this is Fc sine of beta, right? So Fc cos of beta is equal to F. So what is Fc? Value of Fc, the force along connecting rod, can be written as the piston effort. F, what is F? F is piston effort divided by cos of beta, right? So normal thrust to the cylinders, that is the Fn. You can say this is the normal thrust to the cylinder. I can say Fn is equal to Fc sine beta. Now Fc is equal to F by cos beta. So if you substitute this, Fn will become F sine tan beta, right? This is substitute value of Fc, that is F by cos beta. So it will become F sine beta by cos beta, that is equal to F tan beta. So this is the formula. ये थोड़ा सा explain मैं इसलिए कर देता हूँ because again remembering these formulas is next to impossible. At least for me, I can only do it through derivation. ठीक है, I can only do it through derivation. ठीक है, even in exam scenario, I will not try to remember all these formulas. Otherwise, पूरा घपला हो जाएगा. Okay. So ठीक है, fine. So radial thrust to the crank bearing. Right now, this is the force which is transmitted along Fc. This is the force which is transmitted along Fc. Right. This is the force which is transmitted along Fc. Right. Now this Fc component, if you come to the crank end, okay, this is the crank end. This is the crank end. If you come to the crank end, right, again Fc can be resolved into two parts, Ft and Fr. Fc again can be resolved into two parts, Ft and Fr. Now see, ये angle क्या है? What is this angle? This angle is beta. This angle is beta. This angle is theta. So what is the sum of the exterior angle of a triangle? If you see this triangle, if you take this triangle, if you take this triangle, the exterior angle of a triangle, the exterior angle of a triangle is equal to sum of the opposite interior angle. So this angle is theta plus beta. What is this angle? Theta plus beta. What is this angle? This angle is theta plus beta. This angle is theta plus beta. Now radial thrust to the crankshaft bearing. Radial thrust to the crankshaft bearing. So what is the radial thrust? Can I say radial thrust, that is Fr, is equal to Fc cos of theta plus beta. So in terms of F, piston effort, you've already calculated piston effort. What is piston effort? Fc in terms of piston effort is F by cos beta into cos theta plus beta. This is Fr, right? Crank effort is nothing else but Ft is equal to Fc sine of theta plus beta, right? This is what I'm talking about, sine of theta plus beta. So Ft can be written as F by cos beta into sine of theta plus beta. Okay, again these two formulas are worth remembering. Okay, this formula and this formula are worth remembering. Okay, again this formula is more important, this is more important. This is important. ठीक है, देखेंगे because this is directly going to be used in our concept of flywheel, right? So this is all about dynamic and kinematic analysis of slider crank mechanism. They are objective question. If you ask me about objective questions, these formulas can be directly asked, right? Numerical questions becomes a bit tough don't see the possibility of being asked in HL exam, right? Because it requires the use of calculator, because you have sine theta, cos theta, so many values, right? Also, the problems are not very easy to answer. Not very easy to means it is easy, okay, but it takes time. It requires some amount of calculation. So I'm not taking any. Yes, questions has been asked. If numerical, right? Few questions has been asked, 4 to 5 questions in GATE throughout these years, right? But I'm not discussing those questions. Okay, I'm not discussing those questions. Okay, turning moment on the crankshaft. So this is important. This is something important. Turning moment on the crankshaft, right? So what do I mean by turning moment? So if you see what is the force, Fc is the force on the connecting rod. So the connecting rod is transferring the force to the crank, right? Crank. Now there are two types of force on the crank. One is the tangential force. Tangential. One is a tangential force and one is the radial force. One is a tangential force and the other one is a radial force. So which force do you think is responsible for turning the crank? Which force do you think is responsible for turning the crank? Definitely the tangential force. Radial force is not going to turn the crank. It is just going to put pressure on the bearing. So what is going to turn the crank is the tangential force Ft, right? Is the tangential force Ft. So if you talk about Ft, right, we have already found out what is Ft, right? We have already found out what is Ft, right? So now what is a turning moment? Turning moment is nothing else but a torque. Take a torque on the crankshaft. Torque on the crankshaft, right? Turning moment. So this is the shaft. Here it will be, the shaft will be, right? If the crank radius is r, what is crank radius? Crank radius is r. Let me say the crank radius is r. Crank radius is equal to r. So in that case, what I can say is a turning moment, that is a torque, is equal to Ft into r. Turning moment is Ft into r. Turning moment is equal to Ft into r. Turning moment is Ft into r, right? So this is the torque which will actually drive your wheels, because whatever torque is put on the crankshaft, that will get transmitted to wheel, right? It is not the piston effort that is getting transmitted. It is not the connect force on the connecting rod that is transmitted, right? It is not even the Ft which is getting transmitted. It is a torque. There is a turning moment because of the tangential force Ft, which is getting transmitted to the shaft, right? And this through your transmission mechanism, this through your gearbox, transmission shafts, right? It is transferred to the wheels, which actually drive your vehicle, which actually drives your vehicle, right? So I hope this chapter is clear. I hope this chapter is clear, right? This was kinematic and dynamic analysis of single slider crank mechanism. This chapter is important so that you can understand the next chapter, that is flywheel. This chapter is important also because questions are being asked. Okay, definitely questions are being asked from this chapter also, right? So all the formulas you have to remember, or concepts you have to remember, right? Numericals don't expect, just revise through the formulas and the concepts. That's it. Okay. Now if you see the tangential force, that is Ft, which is also known as crank effort, right? This is also known as crank effort. Ft is also known as crank effort, right? This tangential force Ft, which is also known as crank effort, right? Will it be constant? Yes or no? Will it be constant? Do you really think this is going to be constant? Or is it going to vary with angle theta? Is it going to Ft will vary with angle theta? Or is it constant? You can see it very clearly from the formula, right? Ft is varying with angle theta. because with theta, sin theta will vary. Cos beta will also vary, right? Definitely what is going to happen is that the FT, that is the crank effort, it is not constant with time. With time, it is going to vary. With time, it is going to vary. With time, it is going to, as well as if you see the force, that is the piston effort, will it be constant with time? No. Because if you consider an IC engine, there's a four-stroke engine. Let me consider a four-stroke engine, right? How many strokes are there? There are four strokes. Which are the four strokes? The suction, compression, combustion, and exhaust. Out of these four strokes, how many of these four strokes are delivering power? There's only one stroke, that is the expansion stroke, that is delivering power, right? So 25, only 25% of the time there will be this piston effort. The rest of the time there will be no piston effort. In fact, power will be consumed. To compress the fuel air mixture, you have to give power, isn't it? You will have to give power, right? To exhaust, you have to give power, right? To run the suction stroke, you have to give power, right? You're getting power only in one stroke, that is the expansion stroke, right? That is the combustion stroke, or you can say the power stroke, right? And in three of the strokes, power is being consumed. Three of the strokes, the power is being consumed, right? So this is something very unfortunate, right? Only the power is available for 25% of the time, right? And you have to use it throughout. For example, very simple. For example, you are in a job, okay? You are in a job where, okay, you're employed only for 3 months. Let me say, how many months are there in a year? How many months are there in a year? There are 12 months in a year, right? But you are employed only for 3 months, and you are paid a good salary. Let me say you are paid a salary of 6 lakhs in these 3 months, right? So what you are going to do, you'll put this, will you spend all the 6 lakhs of salary in this 3 months? No, you have to plan for the whole year, right? So what you are going to do, you'll put this 6 lakhs in a bank account. You're going to put this 6 lakhs in a bank account, right? Then you spend monthly 50,000. Every month you're going to spend 50,000, so that you can at least spend, you have money throughout the year, so that you have money throughout the year, right? So exactly this is what is happening in case of IC engines also. This is also happening with in case of IC engine and other steam engine also, right? Power is available only for 25% of the time, but you require to drive the vehicle. You cannot say, okay, I'll ride only when there is power stroke. The vehicle will move forward only when there is power stroke. The rest of the 75% time, no, vehicle will not move. This is not what you can do, right? You have to move the vehicle 100% of the time, though the power available is only for 25% of the time. So what will you do? What will you do? What we are going to do is, what we are going to do is, what we are going to do is, we will attach a flywheel. What we are going to do is, we'll attach a flywheel. So how does the flywheel work? This is what we are going to see briefly. How does the flywheel work? We'll see this briefly. Okay. So this is a turning moment diagram of a single slider double acting steam engine. Single slider double acting steam engine. Okay, this is not a single slider. It's not just a single slider crank mechanism. This is single slider. Yes, this is single slider, but double acting. What do I mean by double acting? Double acting means there is pressure from both the sides. Steam will be there from both the sides, right? दोनों साइड में होगा. Double acting means there will be forces from both the sides, right? So what happens? This becomes basically a two-stroke, kind of a two-stroke engine. It will become a kind of a two-stroke, right? Because not two-stroke exactly, because suction compression power exhaust is happening on both the sides. So we'll have, if there are n strokes, n stroke divided by 2, that is will be 50% of the cycle will be delivering power stroke. 50% of the cycle will be delivering power stroke. 50% of the time, since it is double acting, 50% of the time it will deliver double stroke, power stroke. Okay. अभी उसमें बहुत ज्यादा डिस्कशन नहीं करता. Let us come back to the turning moment. So what exactly is turning moment diagram? Is diagram between the torque and theta. We know that the torque, which is equal to ft, crank effort into radius, it varies with theta. Varies with theta, right? So if we draw a diagram between torque and theta, we call it turning moment diagram. We call it turning moment diagram, right? So this is how the power is varying. You can see this is how the power is varying. The torque is varying, right? Torque, it will slightly, if keep on increasing, right, till it reaches 90 degree. Then after 90 degree, when the crank angle again becomes 180, it will become 0. Again it keeps on increasing till 270. Then it will decrease to 360. This is how the torque is available. This is how the torque is available. Unfortunately, it is not a constant torque. It is not a constant torque. What is the requirement? Let me say, what is the requirement? Requirement is something like this. This is the requirement. This is the requirement. T mean. The mean torque. Mean torque is what is the required torque. Mean torque is the what is the required torque, right? So how exactly we'll find out what is the required torque? I just gave you an example. You're getting a salary of 6 lakhs. Into how many months? 12 months. Into how many months? 12 months. That is equal to 0.5 lakhs. That is 50,000 per month. So exactly same thing we are going to do here. How to get T mean? How to get T mean? T mean is equal to the total work done divided by cycle time, right? So here, work done, what is work done here? The work done is area under the t theta diagram. What is work done here? Work done is area under t theta diagram. You can see work done area under t theta diagram. So what is T mean? Cycle time in which one cycle is completed. Time in which one cycle is completed, right? So let me show you just quickly. Let us go through one cycle. What will be one cycle? If you consider the single slider crank mechanism, okay, not double acting, single acting. Let me say, what is one cycle? Let me show you. Okay, when suction stroke, the crank will move from here to here, suction. Then you will have compression stroke. So 360 degree over, crank has, the theta has all sorry 180 degree plus 180 degree, that is 360 degree over, right? 360 degrees over, right? So after that, after compression, there will be the power stroke, and after power stroke, what you are going to have is you're going to have the exhaust stroke. Again, 360 degree movement of the crank. So what is the cycle time for a four cylinder, for a four stroke engine? For four stroke, or simply say single slider, single acting engine. Single slider, single acting engine, I can say the cycle time is 360 into 2, that is 720 degree. Or you can say 4 pi. Since this is a double acting steam engine, means both the sides of the pistons are being used, right? So the cycle time will be half, that is 360 degree. in 360 degree, it will be able to complete one cycle. So what is the cycle time here? It is 360 degree, right? So how to find out T mean? What is the mean torque? So this is the total work given. This is the total work given, right? What is the mean torque? Mean torque can be written as work done by cycle time, right? And what is work done? You can say area under the T theta diagram, right? So you have now T mean. What you have now is T mean. What you have now is T mean, right? So are you able to follow? Are you able to follow each and everything? So this T mean is also known as resisting torque or you can say load torque. Is also known as resisting torque or load torque, right? I hope you're getting this. Okay, I hope you're getting this. Now, now, so any area above the T mean line, any area above the T mean line is excess energy, right? Any area above the T mean line is excess energy, and any area below the T mean line is energy which is below the required energy, right? So because your IC engine is not giving you a continuous constant energy, your IC engine is not giving you constant energy. What you require is T mean. What is required? What is the load torque? What is required? What is required is T mean, but what you are delivered, what you are given is sometime more, sometime less. Sometime where will be given more, sometime will be given more, sometime will be given less. Sometime will be given more, sometime will be given less. Right? So how to use it? What to do? What to do? So in that case, what we have done, we have attached the flywheel. So what will the flywheel do? What will the flywheel do? The flywheel will absorb the excess energy. When there is excess energy, whenever there is excess energy, positive energy, flywheel will absorb the positive energy, absorbs excess energy, and whenever there is deficit of energy deficit, whenever the energy is below the requirement, right, flywheel will deliver required energy, required energy. Flywheel will deliver required energy. So where is the flywheel connected? Where is the flywheel connected? The flywheel is connected to the crankshaft. The flywheel will be connected to the crankshaft, right? I'll give you an example, simple example, a practical example. Have you ever ridden a bicycle? Have you ever ridden a bicycle? Yes or no? Yes, right? So if yes, you might remember that whenever we are riding a bicycle, it used to be very fun for me actually, right? When I was used to be small, what I will do, I will ride the bicycle very fast for some time. Means I'll pedal the bicycle very fast, right? So that the bicycle picks up the speed, right? And after that, I'll simply stop pedaling. I'll simply stop pedaling and I'll try to enjoy the surrounding. I look here, I look there. I'm simply not pedaling, but the bicycle is moving, right? Have you experienced this, right? Initially, for a very short period of time, say 5-10 seconds, I'll speed up the bicycle by moving my pedal very much, right? And then I'll stop pedaling. The bicycle continues to move with the speed for some time, right? Slowly the speed decreases, but yes, it moves on, and that time I'll be enjoying the surrounding, right? And again I'll uh, pedal up the bicycle very fast for some time, and then the bicycle will pick up the speed, and then I'll stop pedaling for some time. This is how it goes, right? So exactly same way the flywheel does. So what is the flywheel? There are two flywheels, right? Even in your bicycle, what are those flywheels? Those flywheels are the cycle rim, right? The cycle, the wheels of the bicycle, they act like a flywheel. The wheels of the bicycle, they act like a flywheel. So when you pedal up, what exactly is happening? Your energy, the energy you're delivering, is getting stored in the wheels of the bicycle, right, in form of kinetic energy. In form of kinetic energy. And slowly, that kinetic energy is released onto, when you're not pedaling, that kinetic energy is released onto keep the bicycle moving, right? And as the kinetic energy of the wheels keep on decreasing, the speed of the bicycle also keeps on decreasing, unless and until you give them some fresh energy by pedaling the bicycle with your legs. Exactly, this is how the flywheel works, right? Whenever there is excess amount of energy, like for example, whenever you're pedaling up, right, excess energy, the flywheel will store the excess energy, and whenever you're not pedaling, that is when you have deficit of energy, some amount of this energy from the flywheel will be slowly transferred to the vehicle, so that the vehicle keeps on moving uninterruptedly, right? So this is how it happens. So let me say, if I attach the flywheel, okay, if I attach the flywheel, something I really need to know, okay, something very important here, right? So this is positive energy, this is positive energy, you can see. This is positive energy, this is positive energy, you can see. This is negative, this is negative, you can see. This is negative, you can see, right? So now this is the minimum point, right? This is the minimum point. Let me, i'll I'll explain it to you, okay? What do I mean by minimum and maximum, right? So after some excess energy, what will happen to this excess energy? The excess energy will be stored in the flywheel. What will happen to the excess energy? The excess energy will be stored in the flywheel, right? So what will happen to the speed of the flywheel? The speed of the flywheel will increase, so it will become maximum at this point. That's why I call it nmax 1. nmax 1, the speed of the flywheel will increase, because just now you have poured in energy to the flywheel. Just now you have poured in energy to the flywheel, so the energy of the flywheel have now increased. Then energy from the flywheel is utilized. Energy from the flywheel is utilized. After the utilization, what will be the speed of the flywheel? It will be minimum. Again, similarly, you'll have a maximum, and again you'll have a minimum. This is how it will go on. This is how it will go on. It will have a minimum, then it will have a maximum, then it will have a minimum, then it will have a maximum. So whenever you have given excess energy to the flywheel, the speed of the flywheel become maximum. Then when consumed, the speed of the flywheel will become minimum. Then again excess energy is given to the flywheel, the speed of the flywheel will become maximum. This is how it will keep on continuing, right? So I've just termed it nmax 1, minimum 1, maximum 1, minimum 2, maximum 2, right? It can go on, right? Now this cycle ends here because the cycle time is 2 pi. If it was a four stroke, sorry, single acting, single slider, single acting engine, right? Case it would have gone on again max 1, min 1, max 1, min 1, max 1, max 2, max 3, max 4, min 1, min 2, min 3, min 4. It would have gone, right? So what I consider is here, what is the maximum? N max I will consider is the maximum of all the maximums. N max 1, comma, N max 2, comma, N max 3, comma, and goes on, right? And what is the minimum of all? Minimum of N mean 1, comma, N mean 2, comma, N mean 3, comma, dot dot dot. This will go on. Right now what I have is two terms, that is maximum of all the speed and minimum of all the speed. This will be required. Why? Because this ratio, that is n max minus n mean divided by n, is called coefficient of fluctuation of velocity. Coefficient of fluctuation of velocity. And this color is good. Coefficient of fluctuation of energy, of speed, sorry, right? What is n here? Let me define what is n here, right? N max, I have already seen what is n max. N mean, I have already seen what is n mean. What is n? This is equal to nothing else but mean, n mean, that is equal to n max plus n mean divided by 2. N max plus n mean divided by 2. N max plus n mean divided by 2. N max plus n mean divided by if the value of CS is 3%, if it is given the value of CS is given as 3%, you will take the numerical value of as 0.03. If it is given plus minus 3%, you'll take the numerical value as 0.06. You'll take the numerical value as 0.06. Right? And there is a term which is known as coefficient of fluctuation of energy. It is given by E max minus E mean divided by work cycle. So this is important. This is very important. Very, very important. Very, very, very important. This is important. This is important. This is very, 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 very important. Okay. Please remember, you should know how to calculate the value of CS. Questions will be there directly or indirectly. Questions might be there directly or indirectly. Now, there is a term called maximum fluctuation of energy. Maximum fluctuation of energy. What is the maximum fluctuation of energy given as? Maximum fluctuation of energy is given by E max. Right? Fluctuation, if I'm calling fluctuation, that will be delta E max. Fluctuation means change. Right? Delta E max. I can write it as half omega max square, or let me tell it this way, kinetic energy maximum minus kinetic energy minimum. What is the maximum kinetic energy? This is rotating. The flywheel will rotate, right? Half I omega max whole square minus half I omega mean whole square, minimum omega whole square. This is the maximum kinetic energy and minimum kinetic energy. Half I and I can take common. Omega max square minus omega minimum square, right? So what is omega max now? Omega max minus omega a square minus b square formula I can apply, right? I can write it as omega max plus omega minimum divided by 2, or okay, I'll do one thing, I'll bring the 2 inside here, right? Into omega max minus omega minimum. Right? I can write it as omega into, what is this? Omega mean, right? Omega max plus omega minimum divided to omega mean. So I'm simply writing it as omega, right? Now this is omega max minus omega minimum, right? What I can do here is I can make this square and I can divide it by omega. So what is omega max minus omega minimum divided by omega? Can I say this is nothing else but CS? So what is delta E max now? Delta E max will become I CS omega square. I CS omega square. This is again a very, very, very important formula, right? I CS omega square. So देखिए, if I'm saying n and omega, this is same, right? Right? The ratio will always remain same. Why? What is omega? Omega is equal to 2 pi n by 60. So if I say omega 1 by omega 2, I can simply directly write it as n1 by n2. Why? Because 2 pi by 60 is constant, it will get cancelled out. Okay, कोई problem नहीं है. So CS can also be written as omega maximum minus omega minimum divided by omega mean. Omega mean. This is also how you can write the value of CS. No issue with that, right? Because 2 pi by 60 will get cancelled out throughout. 2 pi by 60 will get cancelled out throughout. Okay, this is again a very, very important formula to remember. This is again a very important formula to remember. Okay, so there is a question. Okay, just try to attempt this question. Give it two minutes, then I'll solve it for you. Try to attempt this question. Okay, let us see. Were you able to get the answer? Were you able to get the answer? Were you able to proceed? No issue. Okay, let us see. Let us see. This is why we are here for, right? Maximum fluctuation of kinetic energy in engine has been calculated to 2600. So what is given here is it directly given delta E max. Direct formula based पे कोई दिक्कत नहीं है इसमें. ठीक है? Assuming that the engine runs at an average speed. So what is given average speed? Do I mean by average speed? What is mean by average speed? Average speed is nothing else but RPM. It is given in RPM. So and mean, right? The polar mass moment of inertia of the flywheel to keep the fluctuation of speed. So what is given is CS, right? What is being asked is क्या पूछा है आपको क्वेश्चन में the polar mass moment of inertia. So what you're being asked is polar mass moment of inertia. What you're asked here is polar mass moment of inertia of the flywheel. Okay. Now we know the formula. What is the formula? We know the formula direct. This maximum number of questions will be from this formula. Okay. Delta E max is equal to I CS omega square. Right? Everything is given. Yeah. सब चीज दिया हुआ है. You don't have to worry. Is the value of CS given? Yes. Is the value of omega given? Yes. Omega is nothing else. N is given. You have to convert it into omega. Okay. Is the value of delta E max given? Yes. What is the omega? What is the value of omega? 2 pi n by 60. Let us try to calculate it. 2 into pi into 200 divided by 60. Yes. Let us, I'll have to use the calculator, right? We can approximate it, no doubt. Approximate हम कर सकते हैं. This kind of question, you need to approximate the answer. You should know how to use the method of approximation. So it is giving me 2 pi 200 in divided by 60 is 20.94. 20.94. What will be the unit? radian per second. What will be the unit? It will be radian per second. Very nice, graph. Fine, fantastic, right? So what is the value of CS? Plus minus 0.5. If it is plus minus 0.5%, what I'm going to use is 2 into 0.5 by 100. This is how you are going to do. देखिए बहुत ही छोटा सा, but the important thing that I'll tell you is what is percentage. Percentage means divided by 100. What is percentage? Percentage divided by 100. If I'm saying 5%, this is equal to 5 divided by 100. Percent. Per means divide. Cent means 100. Percent. Right? So very easy way. Otherwise, there is a possibility that you make mistake in number of zeros. If you make mistake in number of zeros, you will not get the right answer. Okay? So plus minus 5% means minus 5 to plus 5. So what I can write? 2 times 0.5 plus minus 0.5% means minus 5 to plus 5. 2 times 0.5. Are minus 5 to 0. So 0 to 0.5. Right? Divided by 100 because of the percent. So what it is going to become? 1 divided by 100, that is 0.01. 0.01. Right? So this is the value of CS. I is given as 2600 joule. So what is the value of delta E max is 2600 joule. So what is the value of I? Now all the units are in SI, right? Yes. बताइए. What is the value of I? 2600 divided by 0.01 divided by 20.94 whole square. How much it is coming out to be? 2600 divided by 0.01 is divided by 20.94 whole square. 592.95. 592.95 kg meter square. Kg meter square. Kg meter square. Yes. Kg meter square. Yes. Right. So I hope you got it. बहुत simple है. ठीक है. If you are being asked questions will be from this formula itself. Okay, need not worry. So just remember this formula. Remember what is I, CS, omega, how to calculate CS. Suppose the value of CS is not given, the question might, it is very easy to make the question tough by just giving you, not giving you the value of CS. Instead, they will give you what is the maximum omega, what is the minimum omega. So you can calculate CS from there. Right? That is also a possibility, right? Sometimes instead of asking anything else, you are only asked to calculate the value of CS. So ये सारा चीजें whatever you have seen here is important. Whatever you have seen here is important. So I hope you have understood flywheel in the minimum possible time. I have tried to deliver the maximum content. Okay, in 1 hour, just over 1 hour, right? We have seen dynamic analysis of slider crank mechanism and also flywheel. Now, next is our governors. Now we are going to see governors. Okay, shall we start? Okay, fantastic. So now, to start, what is governors? Again, we will not take 1 hour. Okay, we should be able to complete it within 1 hour, right? Not even, I think in half an hour we should be able to complete it. ठीक है, देखते हैं. Now, so are you able to grasp? Can you comment me on my speed? Is it okay? Is it okay? Are you able to grasp it? Because faster it is, better attention you will have, right? If I become slow, attention becomes poor, right? Your mind will have time to diverge. So it is very important to be fast in our lectures so that, yes, you remain focused for whatever time it is. And after 1.5 hours, you'll get exhausted. So pointless to take class after 1.5 hours to 2 hours, maximum of 2 hours. You need some rest after that. That's all. Okay. Now, what is the requirement of governor? Okay, what is the requirement of governor, right? So we have seen what is the requirement of flywheel because of interfluctuation of speed or interfluctuations, right? So if I talk about fluctuation of energy, so what I'm talking about fluctuation of energy. If I talk about fluctuation of energy, my friend, right? So there are two types of fluctuation possible. What are the two types? The first type is inter cycle. The next one is intra-cycle. Right? What do we mean by intra-cycle? Intra-cycle is a fluctuation of energy you have seen, and we have attached a flywheel for that. Intra-cycle fluctuation. So what do I mean intra-cycle? Intra means within the cycle, means the fluctuation of energy between the suction, compression, power, and exhaust stroke. Right? We have seen that there was a continuous fluctuation of energy, and this was not feasible to put into use. So what we had to do, we had to use a flywheel. Now there is one more type of fluctuation, that is intercycle. I'll try to explain it briefly. देखते हैं, right? For example, you are driving a car. Okay, if you're driving a car, okay, or yes, let me take, because I have to explain it in a minimum possible time. Okay, let me say you're driving a car. Okay, so there are four people in the car. Okay, there are four people in the. So you are going on a bumpy road. Let me say you're going to some hill station. You're going to some hill station, right? You're going to some hill station, right? You just want to enjoy the ride, and you're just driving at a constant speed. You're driving at a constant speed, right? So how is your IC engine performing? You'll have an IC engine inside your car, and the IC engine is having four strokes: suction, compression, power, exhaust. So serially, suction, compression, power, exhaust. This is how it is running. You see, engine is running something like this: suction, compression, power, exhaust. Suction, compression, power, exhaust. Suction, compression, power, exhaust. Right? And suddenly, this steepness of your road increases. Suddenly, the steepness of your road increases. Means now you have more load on the vehicle. Now you have more load on the vehicle. So what will happen? What will happen if you don't change the position of the accelerator? If you don't change the position of the accelerator, if you don't accelerate, so what will happen? If you don't press the accelerator more, what is going to happen? Your engine will get slow because there is more load. The speed of the engine will become slow. It was initially like this. Initially, it was suction, compression, power, exhaust, suction, compression, power, exhaust, suction, compression, power, exhaust. Initially, it was something like this. And once you reach this more steep, means you have to climb up now, the engine speed has become something like this: suction, compression, power, exhaust, suction, compression, power, exhaust, suction, compression, power, exhaust. What has happened? The speed of the engine has decreased, right? And after you have covered that steepness, now suppose, because you're going on a hilly road, right? Now suppose your there is a down on your road. You have to move down now, right? There is a steep downside to the road. So what will happen to the vehicle now? Right, the speed of the vehicle will increase. The IC engine will become fast. Suction, compression, power, exhaust. Suction, compression, power, exhaust. Suction, compression, power, exhaust. Suction, compression, power, exhaust. Right. So this is what is happening. right? Regularly, this is what is happening. Unless and until you change the position of your accelerator, you press the accelerator, you stop pressing the accelerator, this is what is continuously going to happen, right? Initially it was suction, compression, power, exhaust, suction, compression, power, exhaust. Then it changed it to suction, compression, power, exhaust, suction, compression, power, exhaust, and then suddenly changed into suction, compression, power, exhaust, suction, compression, power, exhaust, suction, compression, power, exhaust, suction, compression, power, exhaust. I hope you are able to understand what is intercycle fluctuation of energy. Are you able to understand what is intercycle fluctuation of energy? Yes or no? Right? So this is between different cycles. Initially it was normal, suction, compression, power, exhaust, suction, compression, power, exhaust. Initially it was normal, then it became very slow, suction, compression, power, exhaust, then it became fast, suction, compression, power, exhaust. So this is basically fluctuation among different cycles. Now this is not just in case of IC engine. Now in case of IC engine, you definitely have the driver who can actually press the accelerator, or he can relieve the accelerator and actually change the amount of fuel that is going inside the IC engine, right? You can definitely change it, but it is not everywhere. There are some of the autonomous machines, right, where the load will keep on increasing, right, and and you require a governor to control that intercycle. So, for example, let me say in a power plant, let me say hydraulic power plant or thermal power plant, whatever, right? Now the power plant, okay, we are going to get an example. We're definitely going to have an example on that. Okay? Now the power plant, you see the demand of power within a city keeps on changing, right? For example, daytime it will be more, night it will be less, right? Even within the daytime, it will keep on changing. Lunch hour, automatically all the machines will get shut down. Suppose there are a lot many factories or industries, all the machines during lunch hour will get stopped down, so the power consumption will suddenly decrease, and after lunch again it will increase, right? Evening time again you will have a tea break, again it will decrease, again night it will be switched off. So continuous fluctuation of power requirement is there. Continuous fluctuation of power requirement is there, right? So what exactly we will do? Okay, we are going to use a governor to control this. We are going to use a governor to control this. Let us see how exactly the governor will control, right? So this is the diagram of a centrifugal governor. Centrifugal governor. This is the diagram for a centrifugal governor, right? So what are the things, different things? Let me see. Okay, this is this known as fly balls. ये जो है, this is fly ball. This is the sleeve. You can see sleeve, right? So there is a bell crank lever here. Lever here, right? So this is the turbine. You can see, right? This is the turbine. The turbine is connected to by the engine shaft using mid-tray gears. These are not just bevel gears. We have seen mid-tray gears in last class. These are mid-tray gears. You must be remembering mid-tray gears are bevel gears, exactly same bevel gears, right? So what will happen, because as the engine keeps on rotating, as the engine starts its motion, right, the shaft will start its motion. Because of the shaft will start its motion, the flywheel will also have circular motion. So there will be some amount of centrifugal force, on the flywheel. So the flywheel will move outwards. What will happen? The sleeve will move up as the speed increases. Let me say, as speed increases, what will happen? The centrifugal force will also increase, right? Centrifugal force increase means the flywheel will move outwards. This is the radius of the flywheel. This is known as the radius of the flywheel, and this is the height of the governor, h, height of the governor, and the radius of the flywheel, right? So the fly balls will move outwards. The fly ball will move outwards. the flywheel will move outwards, the flywheel will move outwards. So what will happen? The sleeve will come up because the flywheels are connected to the sleeve will come up. As soon as the sleeve comes up, so what will happen because of this Blankel river? What will happen? The this main valve will get closed, right? This main valve will get closed. As the speed increases, I'll write it here instead. ठीक है, यहाँ लिखते हैं. As speed increases, what is going to happen? Flywheel will move outwards. Moves outwards. As the flywheel moves outwards, what is going to happen? The sleeve will move up. The sleeve is going to move up. If the sleeve moves up, what is going to happen? The main valve will get closed. Main valve will get not fully closed, will get the opening will be reduced. Slightly closed. So if the main valve gets slightly closed, the steam, there is a reduction in steam supply will decrease. If the steam supply decreases, what is going to happen? The power developed in the turbine will be reduced. Power will reduce. So if the power is reduced, what is going to happen? Speed of the turbine will reduce. Speed of the turbine is reduced. So whenever there is a decrease in load, what is going to happen? The speed will increase. Turbine speed will increase. Whenever there is a decrease in load, suppose during the night time, right, the speed, people have, all the industries have shut down, right? People are moving home, right? So what is going to happen? The speed, the total power demand will become low. So power demand becomes low, the speed of the turbine will increase, right? So if the speed increases, now the governor will come into effect. How? The fly balls will move outwards because of the speed increases. The sleeve will move up. If the sleeve moves up, the main valve gets slightly closed. If the main valve gets slightly closed, what is going to happen? The steam supply will reduce. The steam supply reduces. The power developed by the turbine will become less. And if the power developed by the turbine becomes less, the speed will automatically come down. So this is how the power fluctuation is controlled. This is how the power fluctuation is controlled using a governor, right? Okay, there are two types of governor. Now I hope you got it. Right, function of a governor is to maintain the speed of engine within specified limit wherever there is a variation of load. So if there is a variation of load, the speed of the engine can change. So function of a governor is to maintain the speed within a specified limit. Right? Broadly, there are two types of variation: speed variation, intracycle and intercycle. The intracycle is variations controlled by using a flywheel, whereas the intercycle is controlled by using governors. This is what we have already seen. Right? Now, on the basis of working principles, there are two types of governors: centrifugal governor and inertia governor. There are two types of governors: centrifugal governors and inertia governors. Right? Centrifugal governors are more common, and in action, and its action depends on change of angular speed. So centrifugal governor, the action depends on change of angular speed. Right? We have just seen right now, huh? Right? This change of angular speed results in the flywheel moving outside. Because the flywheel moves outside, the sleeves moves up. That's why the valve gets closed slightly. So everything is dependent on the change of angular speed. How much change in angular speed, accordingly how much valve will get closed. If the change in angular speed is much more, if the change in angular speed is more, the valve will get closed more. Accordingly you will get the result, right? Inertia governor on the other hand, right, are operated by rate of change of speed. So which will first come? Is it the change of speed? Rate of change of speed means acceleration. Now acceleration will come before the change of speed, actual speed, right? First there will be force. Because of force there will be change, there will be acceleration produced, and the acceleration will result in change in angular speed, right? So which is going to come first? Acceleration, right? So this the inertia governors, it provides a faster response than centrifugal governors. Please remember, there are two types of governor: inertia and centrifugal. Inertia governors are operated by rate of change of speed. Centrifugal governors are operated by change of angular speed, which provides a faster response. Inertia governor provides a faster response, but which are more common because of the easy construction and easy maintenance of the governors. Centrifugal governors are more common. So basically, there are more than four types of governors now, right? These are the four initial types of governors, right? Watt, Porter, Crowell, Hartel. In the same order they have been invented. In the same order they have been invented. The first governor that came into being was Watt governor by Sir James Watt, right? And this was developed during while he was developing the steam engine. Okay? He faced the problem of this fluctuation of speed when he was developing the steam engine, and then he started developing this governor. So this is this the first one is the Watt governor. Then because there were some shortcomings in the Watt governor, so the new scientist Porter, he developed the Porter governor that was next to come. Then, because of and uh, to create further some improvements, there was a new governor that was the Crowell governor, and then finally we have the spring control governor that is the Hartnell governor. Right? Now it is there are even new types of governors, very high types of governors are used, right? But this is in our syllabus. This is what we are going to have a glimpse through, right? So this is what is a Watt governor, right? So this is also known as pendulum type governor, right? So this is the mass of the flywheel will be mm. There is a sleeve. The sleeve is massless. Please remember that the sleeve is massless. Right? The sleeve is massless, right? So the equation, I'll not go through the derivations and all. ठीक है ना? एक simple सा चीज आप देख लीजिए. What is the equation? If question is being asked, this is what will be asked. Right? This is if the question is asked. This is what is asked. So this is the height. This is the radius of the governor R, and this is the height of the governor H. Right? So H is given by 895 divided by n square mm. 895 divided by m square mm. 895 divided by n square mm. What is n? N is the speed of rotation. What is n? In rpm, definitely. n rpm. इस इक्वेशन से आपको हो सकता है you might be directly asked what is the height of the rope, right? So ये बहुत ही simple है, right? But the problem with this governor is it became ineffective at higher speeds. Became ineffective. Ineffective means what is the role of a governor? That is to control the speed, to keep the speed within the limit. But it became ineffective at higher speeds. Right? So the next improvement was Porter governor. So what he do is simply he had put some weight on the mass. He has simply put some weight on the mass. Now the mass also, the sleeve, sorry, put some weight on the sleeve. The sleeve also has some mass, right? That is in Porter. That is in Porter. Okay, what I'm talking about is Porter. Mass M. This mass M. So mg, and this is capital G. Right? So it brought some change. I'll not go write the equation. The equation is somewhat longer. Okay, for Porter governor equation is somewhat longer. If you want to see, I can write it is something like n square is equal to 895 divided by h 2 mg plus mg plus minus f, I think mg plus minus f 1 plus k, ठीक है, ऐसा कुछ इक्वेशन है, ठीक है. आई ऑल्सो डोंट रिमेंबर इट कंप्लीटली, बिकॉज आई ऑल्सो डोंट रिमेंबर इट. दिस इज समथिंग, सम काइंड ऑफ इक्वेशन लाइक दिस, 2mg plus mg plus minus f, ठीक है. लंबा इक्वेशन है, ठीक है. नीड नॉट रिमेंबर, नॉट एट ऑल नेसेसरी, राइट. बट डेफिनेटली रिमेंबर the series, in what way the governors have been invented, right? What Porter Powell governor, right? So what governor, this equation, yes, definitely you can remember, right? If you go to Powell, इसका अभी मेरे को याद नहीं equation, I don't remember. इसमें और it is even complicated than this, ठीक है. Porter, ठीक है. So what is done in the Porter, these equations are important with subjective point of view, not with objective point of view, okay. Anyways, gate also, they are not asking, because now you have electronic fuel control, like you have electronic fuel control, the slowly the use of governors are also getting obsolete. Use of governors are getting slowly obsolete, because now what we have is electronically controlled fuel supply. So mechanic governors is basically a mechanical control of the fuel supply or steam supply. Nowadays, with the advancement of technology, slowly we are into electronically controlled. So that is why the questions from governors are slowly decreasing, because governors are slowly becoming obsolete, right? But ठीक है, कभी कभार क्वेश्चन पूछ लिया जाता है, right? Even for gate, if you see, only one question that has been asked from governors in so many years. ठीक है, only one question has been asked in gate in the past 30 years. Okay, so that is, you can just feel. Okay, but engineering service questions are asked. Engineering service questions are asked. Okay, even in the mains exam or and also in the prelims section, questions are asked from governors. Okay, then you have Powell. Powell, it is same. It is a dead mass. It has mass on the sleeve. Balls have mass. Only what they have done is they have extended the arms. This is what is important. यहाँ पर अगर important है तो ये चीज है, dead weight. ठीक है. Water governor has put dead weight. Which has extended arms? Powell governors have extended arm. Pendulum governor, which one is the pendulum governor? Watt governor. Equation of the Watt governor, right? Mass is sleeveless. These are some of the important points that you need to remember, right? So you can see the arms were extended, and it helped in improving the function of a governor. The arms were extended. The flywheel were moved up. Then the last one is a spring control governor. Which of the following, question asks like this, which of the following is a spring controlled governor? You will be given the name of all the four governors, and you will be asked the answer, right? So again, the question like this, uh, question like uh, in which of the governor has a massless sleeve? Which of the governors has a massless sleeve? Right. So again, questions will be given four options. So what will be the answer? Answer is the Watt governor. Okay. डिस्कस करके फायदा नहीं है, ठीक है. वी will not be able to, ठीक है, discuss it. इसमें derive करके there is a equation. If you want to write down the equation, you can write down the equation, ठीक है. S is equal to, that is, S is the spring constant, ठीक है. It is equal to, what is the spring constant? A divided by B whole square. A divided by B whole square. F2 minus F1, where F2 is a F2 minus F1. I'll tell you what is F2 and F1. F2 minus F1 divided by R2 minus R1. R2 minus R1. इसके लिए फिर से इसको you have to analyze this. You have to analyze this. ठीक है. F2 and F1 are the spring force. F2 and F1 are spring force at the innermost position and outermost position. Innermost position is, or you can say, the compressed position when at the maximum speed. Spring force at maximum speed, simply saying spring force at maximum speed and minimum speed. A and B, you can see this is arm A, this is arm B. Generally in objective questions, A and B are given as equal. R1 and R2 are the radius of rotation of the fly ball, right? R2 is the radius of rotation at maximum speed, R1 is the radius of rotation at minimum speed. Yes, numerical is possible from this, right? It has never been asked in GATE. Yes, engineering service they have asked, right? So we'll focus according to our GATE syllabus, what has been asked. Now there is a term called stability. Here the most important part begins. There are few concepts which we'll go through. Let us see quickly go through what are the concepts that we'll see. Stability of a governor, sensitivity of a governor, hunting of a governor, controlling force diagram. These four concepts, yes, question can be asked from these concepts. Questions can be asked from these concepts, right? Now the function of the governor is that if n increases, the radius of rotation should increase. Yes or no? If n increases, the radius of rotation should increase. देख लेते हैं एक बार, कोई बात नहीं. Here you have seen, right? The speed, if speed increases, the fly ball has to move out. If the fly ball is moving out, what is happening to the radius? Radius is increasing. N increases implies radius increases. N decreases implies radius decreases. This should be the normal governor. This should be the function of a normal governor. Whenever the speed increases, the radius is increasing. Whenever the speed decreases, the radius is decreasing. Right? This is the normal function of a governor. So if you have a governor where if n increases, r increases, n decreases, you will have r decrease in r. This is called a stable governor. Unfortunately, there, if you make mistake in construction, this is also possible. That is, speed increases, r decreases, or the speed decreases, r increases. This is also possible. This is called a unstable. Unstable governor. And there is also a possibility that you increase the speed, decrease the speed, r is equal to constant. This is also possible. This is called as isochronous. This is known as isochronous governor. So this is also important. Questions from stability of governors are being asked. Questions from stability of governors being asked, right? So stable governor, unstable governor, and isochronous governor, right? Stable, unstable, and isochronous governor, right? Next is the sensitivity of a governor. Next is the sensitivity of a governor. So what is the equation? What is the formula for sensitivity? I'll give you some important questions. Sensitivity can be written as range of speed divided by the mean speed. Range of speed divided by mean speed. So what is the range of speed? Range of speed can be given as n2 minus n1, right? Divided by mean speed. Mean speed can be, sorry, n2 minus n1, or better to say n max. You can say it like this: n max minus n minimum divided by mean speed will be n maximum plus n minimum divided by 2. So sensitivity can be written as 2 times n maximum minus n minimum divided by n maximum plus n minimum. 2 times n maximum minus n minimum. Okay, so sensitivity, this is what is called as sensitivity of a governor. Sensitivity of a governor, right? This is what is called as sensitivity of a governor, right? Now what is the sensitivity of a? Sensitivity of a. Sensitivity of a isochronous governor. So sensitivity of a isochronous governor. What is the sensitivity of a isochronous governor? What is the sensitivity of an isochronous governor? That is something important. The sensitivity of a isochronous governor is infinite. isochronous governor is infinite. ठीक है, this is something important. Questions पूछे जाते हैं. So important. What is the sensitivity of your isochronous governor? That is infinite. Sensitivity of an isochronous governor is infinite. You just seen isochronous governor, right? We just seen isochronous governor. ठीक है, it is something important. ठीक है, there are two questions. What is sensitivity? What is sensitivity, and what is sensitivity of a isochronous governor? Right now, hunting of a governor. Right. Generally, isochronous governor can do hunting. Generally, isochronous governor can do hunting. I'll just explain you. Okay, I'll just explain you what exactly is happening. Okay, so because the sensitivity is infinite, because the sensitivity is infinite, now I'm just drawing the sleeve. Okay, now this is a stop, upper stop, and this is the lower stop, lower. There's the upper stop, and then you have the lower stop, right? And between you have the sleeve. Okay, all of you now know the sleeve is attached to the fly ball, right? You have the sleeve, this kind of sleeve, right? This is the sleeve, right? And a sleeve is attached to the fly ball, right? Fly balls are there, and you have all those things. Okay, I'm not drawing all those things. Okay, I'm just drawing the sleeve. I'm just drawing the sleeve. This is, I think it's the sleeve. Now isochronous governor, we know that the speed is infinite. Sorry, the sensitivity is infinite. We know the sensitivity of a isochronous governor is infinite. Now, let me say there is a slight change in speed. Slight change in speed. Okay, very small change in speed. Okay, very small change in speed. Right? Small change in speed. So what will happen if even if there is a small change in speed, small change in speed, small change in speed, even there is a small change in speed, for example, increase in speed, a small increase in speed, small increase in speed, what is going to happen? Because the sensitivity of a governor is high, there's small increase in speed, but the sleeve will come down more. Because sensitivity is more, the sleeve will come down more, right? So if the sleeve comes down more, what is going to happen? What is going to happen? The valve, the valve is connected through the steam, through the bell crank lever. We have seen, right? The sleeve is connected through the bell crank lever to the valve, right? Let me say there is a fuel valve instead of steam. Let me consider it as a fuel. It will be better, easy to understand, right? So the valve will get opened up, the fuel injector, the fuel valve will get opened up. So a lot of fuel will pour in. If the lot of fuel will pour in, what is going to happen? Suddenly the speed of the increase will increase. Suddenly there will be a very increase in speed. Let me say the speed of the speed of the engine first decreases. Speed decreases. Small decrease in speed. Small decrease in speed. So the bell sleeve will come down. Because the sleeve comes down, the fuel valve, it gets opened up, right? It gets opened up. Now fuel has got into the engine. Now speed increases. Now as soon as the speed increases, since this is a sensitive governor, what will happen? It will sense more, right? So instead of moving little bit, it will move quite high. So if it moves quite high, what is going to happen? The fuel valve will get close much, because it is moving more than required, so it will get close more than required. So automatically the fuel supply will decrease sharply. If the fuel supply decreases sharply, what is going to happen? Suddenly the speed of the increased engine will drop. If the speed of the engine drops suddenly drastically, what is going to happen? Again, now since this is a sensitive governor, the sleeve will quickly move down to the lowermost point. The sleeve will quickly move down to the lowermost point. It will go and hit the lower stop. And as soon as it hits the lower stop, what is going to happen? Suddenly, the fuel valve will open full, right? Lot of fuel will get inside the engine. Suddenly, the speed of the engine will become very high. So what will happen? Now, as the speed of the increases become very high, now this is sensitive governor, right? What will happen? The sleeve will go and hit the upper stop. The sleeve will go and hit the upper stop. As soon as it hits the upper stop, again the fuel valve will close down, speed will drastically reduce, and the sleeve will come and hit the lower stop. As soon as it hits the lower stop, the fuel will be completely cut off. So sorry, the fuel will be fuel valve will open up completely. Lot of fuel will get in. Speed suddenly increases. The sleeve goes and strikes the upper stop. So this will keep on continuing. Okay? Now it is not possible to stop the governor unless and until you switch off the engine, right? So the sleeve will go and hit the upper stop, then lower stop, top, 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 top. It will make a lot of noise, right? This phenomenon is called hunting, right? Questions are being asked about hunting. Why I have explained you so that if the language, because the question will be in form of language, like what is a hunting, then they'll give you a language. You have to identify which language suits most whatever I have given you the explanation. Take whatever explanation I have given you, right? So hunting is possible in which type of governor? In isochronous governor. In which kind of governor hunting is possible? In isochronous governor. Why? Because the sensitivity is very, very high. So hunting is possible in the governors where the sensitivity is very, very high. Now, we'll talk about the last part, that is the controlling force diagram. Here is from where Gate have asked the question. One question that has Gate asked, and that is from controlling force diagram, right? Controlling force diagram. I'm going to give you a very simple, बहुत ज़्यादा हम नहीं बात करते हैं, ठीक है? Let us not get into detail. I'll just give you simply from where the question might be asked. Simply from where the question might be asked. ठीक है ना? I'm drawing three diagrams for controlling force diagram. Okay. So what I have on the x-axis is controlling force. Let me say Fc, controlling force Fc, controlling force Fc, and on the x-axis I have radius, 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 radius. Now, how does the speed curve will look like? Okay, the speed curve will look like something like this. This is n speed, this is n speed, this is n. We pass to the origin speed. Now the controlling force diagram, there can be three possibilities of controlling force diagram. The controlling force diagram can be like this. Controlling force diagram can be like this, coinciding with the speed curve. Controlling force diagram can be like this. Okay. Okay. Now, as if you compare the first one, okay, if I take 2 points, if I take 2 points, for example, let me first discuss the first one. Okay, first one. Let us first discuss the first one. Now, if you consider the first one, if you consider this first one. Now, as we move from right a lower radius to higher radius. As we move from a lower radius to higher radius. As we move from the lower radius to higher radius. Just hold on. Okay. Now, as we move from lower, this is the three possible ways. These are the three possible ways. Right? These are the three possible ways of how a governor can be. How a governor can be. Right. So now, if you see this, okay, this is the controlling force diagram. This is basically the controlling force diagram. FC, controlling force diagram. This is the blue one. The blue line is representing the controlling force diagram. The blue one is representing the controlling force diagram. Now, for a governor to be stable, okay, I can keep on explaining. Okay, if I explain it, it will take around 15 minutes. But I'll just give you the conclusion. The conclusion, anyways, you'll have to remember the conclusion. Okay, for a governor, to be stable, the slope of controlling force curve is blue. Let me say this is curve. That will be better. Controlling force curve. The slope of controlling force curve should be greater than that of the speed curve. Should be greater than that of the speed curve. Okay. Two types of questions might be asked. I'll say which one is most common question and which one has been asked by Kate. Okay. I'll give you. Okay. अभी देखिए. What is the n? N is the red line is nothing else but the speed curve. Okay. N is nothing else but the speed curve, and blue line, that is FC. I can say FC. FC is the blue line, that is the controlling force. Right. Now, for a governor to be stable, the slope of the controlling force curve should be greater than that of the speed curve. Which one is? So in this case, first one, if you see, the slope of the blue line is less than the red line, speed curve. So I can say that this is a unstable governor. This is the first one, is an example of unstable governor. Right. What is this? This is isochronous. This is isochronous. So if the slope of n curve and the controlling force curve is same, it is isochronous. If slope of the FC curve, that is the controlling force curve, is greater than the speed curve, then it is a stable governor. Otherwise, it is a unstable governor. Okay, so this question might be asked, okay, this way. And otherwise, they also give you the equation of the curve, right? For example, here FC, I can write FC as A plus B R. I can write FC as A plus BR, where A and B are constant. A and B are constant. For example, I'll give you a simple trick. When R is equal to 0, when R is equal to 0, there will be FC will have some amount of value, that is A. FC will have some amount of value, that is A. Positive value. FC will have some amount of positive value. What is the equation for isochronous? Equation for isochronous will be FC is equal to BR. FC is equal to BR. And what is the equation for stable governor? FC is equal to A minus BR. A minus BR. You can verify it from this fact. Or better to say BR minus A. That will be good. BR minus A. BR minus A. So when R is 0, when the R is 0, so FC will have a negative value. FC will have a negative value. So you might be given this equation, 4 equations, and you might be asked which of the following is equation of a stable governor or unstable governor or isochronous governor. And this is, or you might be given the diagrams, right? And you might be asked which of the following is representing a stable governor, unstable governor, or isochronous governor. I hope it is clear to you now. Right? So, yes, in 2 hours of time, we have tried to deliver maximum amount of content. In 2 hours of time, we tried to deliver maximum amount of content, right? That is 3 chapters we have done, right? The last 3 chapters, that is, we are going to talk about gyroscope, balancing, and cams and follower. Okay, there will be one more class. Okay, unfortunately, that will only be a recording version. Okay, unfortunately, that will only be a recording version. That is not going to be live. So we'll share the recording to you, right? Because today is the last class, last day of your class. You will require time for study. By tomorrow morning, you'll have the recording. Tomorrow morning, you'll have the recording. Okay, thank you. I'll stop the recording. I'll end the class. Okay, if you have any doubt, you can ask. If you have any doubt, you can ask. No doubts? Great. Okay, in that case, I'll stop the recording. Thank you. Thank you.